Hi everyone, Krishna this side, and I welcome you all to this channel. In this particular video, we will be looking into this particular problem, house robber, and this falls under the dynamic programming. And then mostly, I'll cover just intermediate to advanced level problems on this particular channel. Okay, so yeah, let's just quickly go through this particular problem statement. I'll directly tell you like what it is, and let's go through the example as well, and let's see like how we can solve this one. Okay, so. See, here we have given array of adjacent houses, and we need to rob these houses in a such a way that if we steal the money from this particular house one, the amount that is given for that particular house, we cannot directly rob the second house immediately, okay? Because this will alert the police and we may get captured. So we need to capture the houses in such a way that no two houses are adjacent, and at the end we need to return the maximum amount that we can rob from the houses. Okay, so let's quickly go through the example that we have here: 9, 7, 3, 1. So if I let us suppose if I pick 2, I cannot pick 7, right? Because both are adjacent to each other. Then I can choose 9, right? So once I choose 9, I cannot choose 3 as in because they are adjacent. Then I can choose 1 at the end. Okay, so this gives us 12 as an answer. Then let us suppose if I skip this 2, I can choose 7 as an house and rob them, right? But then I cannot choose 9 here because 7 is addition to the 9. Then I can pick 3 as well here. So this gives us 10. Even I can skip these houses, right? So let us suppose if I choose 7, and if I skip two of them, I pick directly 1. This gives us 8 as an output. So same goes with 2. If I choose 2, out of them any one of the house I can pick, but if I pick any house I cannot rob the original houses, right? So that's the idea. So out of all these possibilities, this is actually giving us the maximum answer. So that's the straightforward question that we have. So let's see like how we can solve it. So any dynamic programming problems we are trying to solve, we actually try to compute the results, and based on the results, we try to solve the further questions. Okay, so whatever the solution that we get, again that we utilize solving the uh, uh, upcoming results. Okay, so yeah, let's see like how we can do it. Let me get the length of this array first. Nums dot length. So see if the length is 1, okay, then we can simply return the first house as the maximum answer, right? So nums of 0. Okay, if length is 2, then we can return math dot max between nums of 0 and nums of 1, right? So that's what we can do it, right? So I was just trying to explain you like if two of them are there, only two houses are there, so either max amount that is there in house, which that's what we can return. Okay, so let us suppose if there are more than three houses, right? So we are just going step by step. So if now okay, what I'll do is to compute the further results, I'll create here a dp array, okay, which is having the same length, nums dot length. I already get that length, and we will go through I equals to I less than length I plus plus. Okay, from the second index, that is like third house, from the third house we are actually trying to get the results. And for the zeroth position, of course the whatever the nums of 0 is there, that will be there, and dp of 1 will hold nums of math dot max between nums of 0 comma nums of 1. Okay, so why I'm doing this, I'll explain you guys. So we can remove this statement as well, okay, by that way. So yeah, here let's now try to solve the further problems. Okay, so dp of I equals math dot max between dp of this current I minus 2 plus because we are computing for the second index, right? So for this particular 9, what we can do is this number, okay, nums of I plus this particular index, but that will be from the dp array. Okay, or dp of I minus 1, whatever the maximum is there, that is what we will be storing it into the dp array, and at the end we return the dp of length minus 1, last index. So what I have done here, I'll explain you through the example. Okay, so see, I have created a DP array now, and let's go through this example again. 9, 3, 1, and in this particular one, at the zeroth index, of course, if there is only single house, so the answer will be 2. If there are two houses, then the maximum out of them, that is going to be answer. So at the DP of 1, I stored the mat.max between them, right? So 7 is the answer. And then at the third index, right? So what we are now, from the, sorry, from the second index, that is the third house, from the third house we are computing the results. So what we are doing at this particular index, so at 9, at the third house, what we are doing, this particular value, that is 9 plus, we are not going to consider the addition house. So whatever the maximum answer we get till this index, that we are actually storing it at all the indexes, right? So indices, right? So 9 plus a dp of this particular one. So this is the dp array. Okay, let me put here a dp array, and this is the nums array. Okay, so dp array and nums array. So in the dp array we have these values, and in the nums array these are the values, right? So what we are doing at this particular one, dp of I minus 2. So we are considering this one. Okay, I minus 2 means I is 2, 2 minus 2 is dp of 0, dp of 0 we have 2, and the nums of I is like 9 currently. So 9 plus 2, that is what, 11. So we are considering 11, or this particular one, whatever the maximum answer we have, that is what we are actually storing. So why we are storing the maximum answer means, like further, like going ahead again, here it is 11, right? So further at this particular index, now we reach at this particular index. Okay, so 3 plus, I'll consider this dp of 7, that is 10, or the maximum of this one. Okay, dp of I minus 1, this is 11, right? So 11 or 10, which is the maximum? 11 is the maximum, right? So that's the maximum answer what we are trying to store at each index, so that at any point in time, so if I go further and at any index, if let us suppose the previous index has the maximum answer, right? So why I need to consider skipping the this previous index and get the answer from the dp array plus this nums of 5. So if I am getting at this particular index, maximum is this one, right? From either we are considering 7 plus 3 or previous one. So if I am getting the maximum answer, this one definitely I will consider that answer as a maximum answer, right? At this particular index, what I'll do is like 1 is there, right? So 1 plus 11, that is 12, according to this formula, right? So 1 plus 11, that is 12, or this 11, which is the maximum? Definitely 12 is the maximum, right? So that's what we are returning at the end. So at the end, dp of len minus 1, that is the last, for the last index, whatever the maximum answer that is there is going to be our returning answer. Okay, so that's what we are doing. So even if there is len 3, so at the end, at each index, the maximum answer is what we are actually storing it, right? So let us suppose instead of 2, here it is 7, and here it is 2. So what our dp array would look like, here it is 7, and again dp of 1 is going to be 7, because at each index we are trying to store the maximum answer that we will be getting out of them. So either I pick this and maximum answer I got till this one, that is from the dp array that we are computing, or the previous of dp of array, right? So at this index 7 is the answer. Then again 7 plus 9 plus 7, that is going to be around 16, or else 7. So yes, definitely here it will be 16. Okay, again for 3 plus 7, that is 10, or 16. What is the maximum? 16 is the maximum, right? So definitely we will be storing 16 here. Again 1 plus 16 or 16, what is the maximum? Of course 17 is going to be maximum, right? So at the end 17 will 17 is the answer that we will be returning at the end. So that's what we are trying to do here. And yeah, this time complexity here, it is going to be definitely big O of n, because we are traversing through entire array, and we are trying to compute the array into a TP1. So space complexity from this one is big O of n, of course, because we are creating a DP array of length n. Okay, so yes, both are becoming big of n, but we can optimize the space complexity further, because we, by looking into this particular one, it is just we are just trying to consider two of the DP arrays, right? So the last one and the second last one from the DP, right? So we can further optimize it. Instead of DP here, what I'll do is DP of 0 will be previous of previous. That's what I'll name it here, and here it will be previous. previous one. Okay. So yeah, math between the that sort here, and here we are computing for the current one. So int current equals to mat dot max dp of I minus 2, that is going to be previous of previous, previous of previous plus nums of I, and dp of I minus 1, that is going to be our previous. Now I just need to update the both previous of previous and previous these states, right? So previous of previous is going to be math dot max between previous of this previous or else previous one, whatever the maximum, and the previous is going to be math dot max between previous comma current one. Okay, so whatever the maximum that we are actually trying to store here, and at the end dp of len minus 1, that is going to be previous. That's what we are trying to return here. So this way also we are just trying to optimize the space, and in this particular way we just reduce the space complexity to constant. Okay, so it's going to be big of one, we can say that. So that's how we can optimize the space as well. And let me run this code. So we can see that it is getting accepted. So even if we submit it, this will getting accepted. Okay, so there is similar problem again with this particular one. I'll just cover that in next video, and till then, see you soon. Bye bye.